Hi, this is Merlin. Today I'm just gonna talk about today. Today the main topic is the B tree. Um, I'm just gonna recap the B tree insertion part and also why we made some kind of B tree. Um, what do you think B tree? B tree is kind of the tree data structure that tree data structure. Like most of people knows that the limitation of the normal binary tree or so binary search tree, and but you have to or know that some kind of data structure are not just made because the data structure limitation of itself. I mean, like, if some kind of data structure, I mean, like, so what I'm trying to say is, yes, the based on the limitation of the data structure, the new data structure can be made, but the core thing is that it's not really data structure itself. It's that the software that utilizes data structure. Example, you have the database. Let's say your database. In database, you have some kind of the unit of your data, which is called record. But rather than and in record, there's a key, which is there's an ID known as the key. It's just a unique ID in the record data. So there are a bunch of records in the database. Example, you have employee, and the employee recap already have unique ID based on them. So of course the ID. So ID is gonna be the key is gonna be unique, but rather than we traverse like we look at the key every time when we're trying to look up some kind of the data, we're trying to figure out we're trying to like doing this way. We gather this key into one file which is called index. So why doing is some kind of this? So rather than putting like looking up some kind of object inside the record or property inside the record, we can just look up the index file that is the sets of the keys. But if there's like if this index file, let's say, if this index file is, let's say, what else? If index file is just the array, just the plain array. So what I mean plain array is it's just the array that the element is the key. But problem is that if your records have like over 1 million data, and you have to find some kind of 1000 key, the key that is has a 1000 value, you have to traverse until you hit the 1000. So that's really unnecessary. So that is why the binary trees come from. We don't have to. The main purpose is we don't have to traverse. For example, you have this key. The purpose of the binary tree, you don't have to traverse all of the child, not child. It's just the key that you don't have to. You don't have to traverse all of this keys to get your target key. The main goal is to reduce the traverse key, to reduce the traverse and beat that. So this is why we do it like this. So binary tree is very simple. You go 3 and 2. If it's like really big, it is like bigger than your root, you go right of your current root. So it's gonna be here 4, and if it's smaller, you go here 2. So example, if you're gonna try to search the 4, and you of course you have to traverse 3 and 4, right? So that also means that we can skip the 2 rather than fully traversing the all of the nodes up here. So this kind of binary tree is really efficient, but the problem is that the binary tree binary tree can have only single child, and rather than this is gonna be our best way, but it can be like this. It can be like this and like this and like this. Since if the depth of the tree is gonna be increase the time complexity, we now trying to solve the other issue, that the unbalanced issue. We can just do the balanced thing, but we just trying to do the new algorithm data structure, which is called B-tree. So B-tree is like the one node have multiple keys, example 2, 3, 4, and what else, and you can just have multiple keys, and based on that you can point the left or right here. So if your example, let's say your current max keys in your one node is 3, that means that the node here, so node here is gonna be let's say max key is 3, so node can have only 2 keys. If it's 3, you have to, it is kind of overflow. So this one node can have 2 pointer. But what if there's 2 of it? Since there's 2, but ours, and that means that we can just use the duplicates. So that means that we change it into 3. If there's 3, if there's more R key there, we can just make it like this. So basically that means that we can have the pointer, 1 pointer and 2 pointers, 3 pointer and a 4 pointer. The pointer that your node gonna get is your max keys and plus 1. So this is how the for line is being made. So this kind of like brief introduction of the B-tree. So this is the Have a nice day. See you next time. Bye bye.